Hello, welcome to my channel. The X. Have you ever wondered what the sound barrier is? Our journey begins with this intriguing question. Contrary to what its name might suggest, the sound barrier is not a physical wall or boundary. Instead, it's a fascinating phenomenon that occurs when an object moves through air at the speed of sound. You see, as an object accelerates, it pushes against air molecules, creating a pressure wave. When this object reaches the speed of sound, about 762 miles per hour at sea level, these pressure waves can't get out of the way fast enough. They pile up, forming a shock wave. This is where the term sound barrier comes from. It's like an invisible speed bump, causing a dramatic increase in aerodynamic drag. The object needs to exert more energy to overcome this drag, kind of like pushing through a wall of resistance. So, in essence, the sound barrier is more of a sound speed limit. But what does speed of sound mean? Is it constant? Let's delve into this. The speed of sound refers to how quickly a sound wave can travel through a medium. However, it's not a one-size-fits-all concept. In fact, it varies based on two key factors: the temperature and the medium through which it travels. For instance, sound travels at different speeds through air, water, and steel. The speed of sound is also impacted by temperature. As the temperature increases, so does the speed of sound. Now, let's talk numbers. At sea level, in conditions of normal room temperature, the speed of sound is approximately 343 meters per second. Yes, you heard it right, that's over 1,000 kilometers per hour. But remember, this speed isn't set in stone. It changes with variations in temperature and medium. Therefore, the speed of sound isn't a fixed number, but changes depending on where and when you measure it. So what happens when something breaks this so-called sound barrier? Well, the first thing to note is that breaking the sound barrier isn't about shattering a physical wall. It's about surpassing a certain speed, the speed of sound. When an object moves faster than the speed of sound, it's said to have broken the sound barrier. And the most well-known phenomenon associated with this is the formation of a sonic boom. But what exactly is a sonic boom? Imagine a boat sailing through water. The boat creates waves that move away from it, right? Now picture an aircraft flying faster than the speed of sound. It's also creating waves, but these are sound waves. And because the aircraft is moving faster than the sound waves it's producing, it essentially overtakes them. This leads to the sound waves getting compressed or squashed together, forming a pressure wave. This pressure wave is what we call a shock wave. And it's the shock wave that causes the sudden change in pressure, temperature, and density that we experience on the ground. It's like a sudden clap of thunder, and it's this shock wave that we hear as a sonic boom. So, when you hear a sonic boom, it's a sign that an object, often an aircraft, has just broken the sound barrier. It's a testament to the incredible speeds that human technology can achieve. Breaking the sound barrier, therefore, is associated with a sonic boom, a loud and distinctive noise. Why does understanding and overcoming the sound barrier matter? That's the question we're diving into now. The sound barrier is not just a concept to marvel at, but it plays a significant role in our daily lives, especially in areas like aviation, space travel, and even medical science. In aviation, the understanding of the sound barrier is crucial. It has allowed us to design and build supersonic aircraft that can travel faster than the speed of sound. These supersonic jets, like the Concorde, have been able to cut flight times in half, revolutionizing travel as we know it. Space travel, another frontier where the sound barrier plays a significant role, has its own set of challenges. Rockets have to break the sound barrier to reach space, and they must do so without breaking apart. This requires a deep understanding of the forces involved, leading to innovative designs and materials that can withstand the intense pressure. And let's not forget medical science. Techniques like ultrasound use sound waves to create images of the inside of the body. Understanding the sound barrier helps us to improve these techniques, making them safer and more effective. However, breaking the sound barrier also poses challenges, such as the sonic boom, which can cause noise pollution and structural damage. To mitigate these effects, researchers are developing new technologies and strategies like designing quieter, supersonic jets. In conclusion, the sound barrier is a fascinating and complex phenomenon that continues to impact our world in surprising ways. Thanks for watching. Subscribe for more interesting videos like this. Have a nice day.